In Chapter 7, we will be talking about rational expressions. We'll talk about how to simplify them, how to multiply, divide, add, and subtract, along with solving equations. In doing this, we'll be using a lot of our factoring skills we did in the last chapter. The first thing that we're going to talk about in section 7.1 is domain restrictions for rational expressions. Now, you'll probably recall that if I have a rational expression or just a general fraction, there's a certain number that the denominator cannot equal, and that is 0. Because if we tried to divide by 0, the function would be undefined at that point. So what you do in order to find any restrictions in the domain is you take the denominator and you set it equal to 0. And then you solve for all the variables that would solve that equation, making it 0. So in this case, the equation is factorable, so we'll factor it. We'll get x minus 3 and x plus 2. And if I solve each one of these binomials, we'll get x equals 3 and x equals negative 2. Therefore, the restrictions of this function is that x cannot equal 3 or negative 2. It can be any other number besides for those two. Now, what happens in the graph usually is you have asymptotes. And what an asymptote is when you have a graph and it starts approaching this imaginary number, and although it approaches, it will never actually get there. And that happens, again, at those domain restrictions. Now, if we look at number 2 and I want to know what the domain restriction is, again, I look at the denominator and I set that to 0. You'll notice in this one, though, that 5 equaling 0, there's nothing to solve for. Therefore, there is actually no domain restriction. And if you think about what this graph actually is, it's 2/5 x plus 3/5. And that's actually a linear equation. So if you think back to a couple chapters ago of how we graphed that, we'd have a linear line, and you'll see that continues in both directions, to the left and to the right. Therefore, it would have no domain restrictions. The next part of this section is we are going to simplify rational expressions. Again, we're going to do this by using our factoring skills from the previous sections. So what you are going to do is you are going to factor the numerator and factor the denominator if it is possible. The numerator can be factored to y plus 3 and y minus 1. Again, two numbers that multiply to negative 3 but add to positive 2. And I'll do the same thing in the denominator. I want to get y minus 2 and y minus 1. From there, we're going to just kind of use our properties of division. Anything in the numerator that's the same in the denominator will cancel out. And we are left with y plus 3 over y minus 2. If we look at example number 4, y minus 2 over 2 minus y, you might say to yourself, well, they're not exactly the same, so they can't cancel. Or you might recognize that they look very similar. Here's y, and there's y. There's 2, and there's 2. But they're opposite signs. This is positive, that's negative, and then the same happens with the 2's. If that happens, usually that can be reduced. What you'll notice is that we'll keep the numerator the same. We'll use the commutative property to switch around the denominator. And then what we'll do is we will take out a negative 1 out of the denominator to change the signs. And from there, we can actually cancel out the y minus 2's, which reduces down to negative 1. That's kind of a trick that will kind of happen a few times in your homework, so make sure you switch it, take out the negative 1. And finally, we're going to simplify when we see multiplication and division as well. And if you remember back to multiplication of rational expressions, just with regular numbers, what you do is you just multiply across and you multiply the denominators. Well, if we try to multiply across here with a binomial times a trinomial, it would get pretty messy. It would be a pretty long polynomial, and things wouldn't cancel out. So what you want to do is you're going to, again, do your factoring properties, and you're going to try to simplify. In the first numerator, I can take out a c, so I'm going to get c plus 2. In the denominator is a dots problem. I'll get c minus 2, c plus 2. And over here, in the second numerator, factors to c minus 2, c minus 2. And then finally, down in the second denominator, we can take out another c. And because it's a multiplication property and you're really just multiplying across, what I'm going to do is I'm just going to extend the fraction bar. From there, I can start canceling out. This c minus 2 and minus 2 will cancel out. And actually, there should be a c minus 1 right here. The c that we took out is a GCF, can cancel. And the c plus 2's. And what we're left with in the numerator is c minus 2 and c minus 1. Now, thing to point out, you cannot just cancel out the c's because they are attached with subtraction to the 2 in the numerator and a 1 in the denominator. And the only way to get rid of a fraction, because this is division, is if this was multiplication in there. So since it's not connected with multiplication, those have to stay connected together as a binomial, and you cannot just reduce it to 2 over 1, which would be 2. We're going to do the same thing in number 6. We're going to factor the numerator here. That's m minus 4, m plus 4, over m plus 2. And you'll notice that the denominators of these don't cancel. So we'll cancel out the numerator here, denominator here, left with m minus 4, m plus 2. Again, those m's don't cancel, and the 4 and the 2 don't reduce because they're connected here with addition and subtraction. And finally, we have our last problem for the video. We have a division problem, 8a squared minus 6a minus 9 over 6a squared minus 5a minus 6 divided by 4a squared plus 11a plus 6 over 9a squared plus 12 plus 4. Now, what I'm going to do is I'm going to do the same thing as I did before with this first fraction. I am going to factor it. Again, you can use guessing or checking, or you can use the factoring by grouping. I'll factor by grouping for the first one just to give you a refresher on that. And then the next two I'm going to factor just by guess and test. 8a squared minus 6a minus 9. I'll multiply the first and last and get negative 72. I'll find the factor pairs that add to give me the middle number, which happen to be 6 and 12. So I'll use that to split the middle into two terms from this negative 6a. I'll split the 4 terms, taking out the GCF out of each one. And then I'll regroup 4a plus 3 and 2a minus 3. Now, in the denominator, what you'll get is 2a minus 3 times the quantity 3a plus 2. Now, the difference between division and multiplication is if you have a division sign, you are really multiplying by the reciprocal. So we switch around the numerator and the denominator, and then we'll factor those individually again like we did the last. So the numerator right here will be a PST, which is 3a plus 2. 3a plus 2. Now you could write that squared, but because we'll be canceling, I write it as two different ones. And your denominator will be 4a plus 3 times 20a plus 2. Now I'll start canceling. 4a plus 3 cancels here with the numerator, here with the denominator. 3a plus 2 cancels there. 2a minus 3 cancels there. And we're left with 3a plus 2 over a plus 2.